Let's get right into the meat of this meetup, and I'm very excited to hear all about it. So Nicholas, on to you.
Hey, thank you, and good evening to everyone who's joining us. So quickly, I'll just drop a blog into the chat. We did announce recently that Azure Sentinel is now GA in Azure Gov. And so you have this capability available to you. So if you haven't heard about Azure Sentinel, it's our cloud native SIM product that we've built using a couple different other products underneath, such as Azure Logic Apps, Azure Log Analytics. But it really allows you to build or deploy a cloud native SIM where you don't need any hardware or software, and you can scale starting at 1 gigabyte a day all the way up to several terabytes per day, petabytes per day. We have some large customers uploading lots of data. So here's kind of the first blade you see when you log into Azure Sentinel. And with any SIM, it all starts about getting your data in with data connectors. And so in Azure Sentinel, what we've done is create a bunch of out-of-the-box connectors. We're continuing to add to these connectors. We're working with partners to build connectors for their products. So you'll continue to see this list grow over time. But what we want to do is make this as simple as possible to connect these products. So for a lot of our cloud native solutions, you can easily hit connect. As you can see, I already have this one connected. It would ask for an authorization, and then the product would be connected. So you don't have to go do anything special or any type of configuration. Obviously, for other things like third-party appliances on-premise, like firewalls, proxies, we have a thing we call common event format, which is basically using syslog to get that data. So you would deploy a virtual machine as a collector, and we have a nice script here you can run that will install our agent, and it will configure the box ready to collect for Ceph. So we try to make this as easy as possible for you to get the data in. As you can see, we have a bunch of third parties. We've worked with some third parties like F5. They have built capability in their product to natively write data to Azure Sentinel. So we encourage vendors to do that as well. So you can see here we have Office, obviously all the Microsoft things, as well as third parties like Fortinet, Palo Alto, and some of your other big firewall proxy vendors. On the data connectors page, when you click on a connector, you can see kind of quickly the green light showing it's connected, kind of how much data you've been receiving in the last week. And you can click on Open Connector page, and here we show you any connector configuration, as well as under Next Steps, you can see any recommended workbooks. Workbooks is our ways to visualize data, any sample queries that you might want to run to see that data, and any relevant analytic templates based on that data set. But once you have data connected, it's all about creating analytic rules so that you can alert on those on that data that's coming in. And so I want to talk a little bit about the different types of rule templates that we have. So I'm going to sort this here by rule type. So first, kind of one of the powers of the cloud you get with using Azure Sentinel is we have a capability we call Fusion. And we use machine learning to look and see if two alerts are part of the same attack kill chain. So here, kind of the first one we released out of the box is we will look and see if Azure Active Directory Identity Protection has a security alert, as well as Microsoft Cloud App Security having a security alert. And if they're part of the same attack kill chain, we will fuse them together into one single incident for you. So that's some power you get of our cloud. The next type is a Microsoft Security Alert rule. Here we are just basically saying any alert that comes from Azure Security Center IoT, go ahead and generate an incident for me. You can also filter these down by severity. So maybe you only want highs or mediums and highs. You can filter out or filter in any specific alert name you want, but these will create incidents anytime you get an alert for one of those native Microsoft security products. Another type of ML that we provide for you and you can enable in your environment is one such as this. So here we took an ML model we were already using in Azure Active Directory to identify anomalous logins, and we applied it to SSH data that comes in via syslog. And so you get that same power of our ML applied to your syslog data, and now we can alert you when you have an anomalous SSH login detection. We have some more coming for this, like RDP detection and a few others in the pipeline that we're working on. And the last type of rule type that we have here is what we call a scheduled query rule. So this is your typical SIM rule where you have a query that runs every so many minutes against so much data and alerts if something is triggered inside of that query. So I'm actually going to walk you through the query rule because I think we've added some capabilities here to make it really easy, and some important notes you should know as you move down this path. So I'll just call this test rule, if I could type today. Obviously, you can add your description. You can pick any MITRE tactics that would apply to this alert rule. What severity you want it to create the incident as, low, medium, high, or informational, and then obviously enabled or disabled. Now, one of the really cool things we did is we leveraged log analytics underneath, which has a query language we call Custo query language. It's very much like SQL, but a little bit different. And we leverage their IntelliSense capability. So here I can type security event or start to type it, and you can see I've enumerated all the different data types underneath in log analytics. So if I click on this, what will happen is that query will actually run in real time, and now I can see I'm getting about 180,000 events every so often. I think this is every at 5 p.m. and then again the next day, right? So this is like a time over windows. I'm sorry, time over hours. And then as you start to filter it out, the same thing would happen. So if I want to say where process name, I'm horrible at typing today, is equal to PowerShell. Maybe I'm looking for some malicious PowerShell running in my environment. We can see here that we don't really have PowerShell running in our environment, but that's okay. We may not want this to run in our environment. So you can also click here to view the results of that data and see with the actual data set that comes in. Won't spend a lot of time on that. But the next important step is to map entities. And why this is important, I will show you more in investigation. But basically what you're doing is saying what column from the returned data is the account or the host or the IP or the URL. And so you can add this to the query, or you can select this list, and we'll show you, again, we pull this in real time, all the data that was returned as part of your query. And so I know for security events that the account is user principal name. So I can go down here and select user principal name, and I could click add, and you can see it just adds a another layer to the query that says extend, which adds a field to the returned data, account custom entity equal to the user principal name. So you can type these in if you want as you get more proficient in deploying these. Next, you set how often you want to run that query over how much data you want to look back on. And so it's important to know kind of what you're looking for, because I'll take one type of attack in two different models here. So a brute force attack, you may want to run that query every 5 minutes to see if I have a failure against my account over 10 times, right? And that's somebody brute forcing my account, trying a bunch of different passwords. But if the attacker is going low and slow and they're trying one password per day over 14 days, then you may want to look for, run the query every day, and you can change this to days. And I want to look back over the last 14 days of data. And now I can see that I'm looking back on a longer period of time, and I'm only running that once a day, because you probably want to look at different windows. And then you can set your alert threshold. What I think is really cool about this, if I want to say anytime it goes greater than 1, you can see here this red line is your threshold. The blue line is the return of your security query. And so anytime the blue line crosses the red line, it would generate an alert. So let's see if I can get this to do something else. Where event ID is equal to 4688, which is process execution. And I knew I was going to type it ID wrong. Come on, there we go. So here we can see we've had a lot of process execution over the last 14 days in our environment. But if I was going to say this is anytime this crosses 200,000, you can see that the red line's here. And now that it's gone over every time this query runs, which is once a day, it's going to report an incident, right? As long as that value is over 2,000 or 200,000. So we'll just set this back. You can also do suppression, so you can suppress the alert if it happens multiple times. So if you had a chart that was looking like this, maybe you want to suppress it for a few days after the incident creates. We've also added a new preview here on incident settings. So by default, we create an incident, which is where you go and investigate these security alerts when they happen. But you can also disable this. So maybe you just want to generate a security alert in the security alerts table, and then have a different rule that's looking for multiple security alerts and correlating those together. So this allows you to do security alert correlation across those. You can also group them. So we can, instead of creating one every time, you can say, go ahead and group this if it's based on the same entities, or if it's part of, triggered by all alerts, grouping all alerts triggered by this rule into a single incident. So instead of getting 10 incidents, you would get one grouped with all the returned results. And then next, you can run an Azure Logic App playbook. So you can do automated response. And this could be something simple like post a message in Teams or open a ServiceNow ticket, or it could even be more complex where you can reduce the workload on your SOC by automating responses. So for example, we have some playbooks here, and if we have time, I'll show you one where you can send an email to the user. Maybe there's an impossible travel. You ask their manager, hey, are they actually traveling to this country? And the manager has two buttons. One says yes, one says no. And if they say no, then maybe you disable the account. If they say yes, you close the ticket and mark the incident closed. So you can automate your responses, your security responses to some of these without having to have the SOC investigate those. So I'm not going to save this, but we'll go back here to analytics, and you can see we have a bunch in here. We have some scheduled queries that are using our TI data or threat intelligence data that's been brought in from various methods. You can bring in threat intelligence from Styx Taxi. You can also use the Microsoft Security Graph to push in threat intelligence data. But once you have an analytic rule and you're generating incidents in your environment, you'll come to this blade where you can actually look at those incidents. And so you can see we have quite a few DDoS attacks going on in our environment coming from Azure Security Center. You can see which ones are created by Azure Sentinel from your rules versus those native products. And so here we can take this use of malicious URL. And here we can quickly just kind of glance at and see what's the severity, what's the status. If someone's assigned, you can drop this down and assign anyone in your Azure Active Directory. You can see the tactic, if anybody adds any tags, as well as if you click on evidence, it will actually return the query results that generated this alert. And then you can see the entities. Remember, I talked about mapping entities. You can see there was 10 IP addresses involved and one URL. You can also add comments. If you click View Full Details, it will take you to the Details blade, and here you can see the actual security alert from the underlying table. I can also manually run a playbook here, so maybe I want to go enrich this incident with data, so maybe I want to look up those IPs against a GeoIP database. And so like we have one I created that gets the IP reputation from buyer's total. And so it writes that data back to the comments of the thing, so you could run that to enrich it. And then, more importantly, when you want to investigate this, you click the Investigate button. And here you can see this use of malicious URLs. We can see the IP addresses, we can see the URL. And we've built this investigation dashboard to kind of change the way SOC analysts respond or investigate to incidents. The way I've done it in the past is you open your SIEM product, you see an alert, you open a new tab, you run a query to say, hey, show me the account that was involved in this, and then show me other things that were going on with that, or show me other events that were on the machine. And so you're asking all these questions, but you're opening tabs and it's a whole bunch of lists of data. And so what we've done is give you the ability to come in here and start to ask those questions. And so you can see we quickly, in real time, ran a query underneath and pulled back the number of results that are related alerts. But if I actually click this, we will build that out, and we can see here that there's about 143 of these. So we have this running in our environment quite frequently. Same thing here. I could say, are there any other related alerts for this IP address? It's going to run that query and let me know if there's any, as well as if I click it, it will graph it out. So you can see we've built some pre-canned questions that you may want to ask of an entity when investigating it. That's why entities are very important when you're investigating them. You can also click on any of the items in your graph here and click on info. So here we can see the details of that alert. I can click on the IP address and see any details that might be coming from that IP address, as well as the URL. And one of the other powers of the cloud, and my screenshot's not going to load. Maybe. Nope. Bummer. So if you have a URL that is mapped as an entity as part of a security alert, when it runs in an incident, we will take that URL and we will detonate it in a black box VM in Azure for you, right? So it's in our cloud service. It's not run as your user or anything. We just basically take the URL and detonate it in a VM, and then look to see if we believe it's some type of malicious URL or whether it's a bad URL or a good URL or bad URL. And so here you can see this was a good URL. For some reason, my screenshot doesn't want to work today, but normally we would capture a screenshot from that VM when the URL was clicked. So you would see what the user might see had they clicked on it. Again, some more power of running in Azure that we provide to you as part of Azure Sentinel. All right. How are we doing on time? Okay, so we got a little bit of time left. So I'll show you two other areas here in workbooks and playbooks. So workbooks is our visualizations of your data in Azure Sentinel. You can see here all of the different playbook templates we have. We actually pull these from our GitHub repo, which I will also encourage you to check out. But here you can contribute your own, as well as you can see all the templates we have in our environment. And so I can view this saved template that I've already deployed to my environment. Why is that not the right one? Sorry, I clicked the wrong one. So here we can see all of the different security alerts coming into our environment, as well as the different entities down here. So I've pulled out the top entities in the security alerts and counted them up or summarized them into count. But some cool things you can do here, you can change the time range as a parameter. So if I change this to the last 28 days, all of these different graphics will update based on that because I've set them to use that as a parameter. I can also filter down by alert severity or product name. I've also set it up so that when you click on one of these parts, so if I click on high, it will pass that out as a parameter to the following web parts. And so you can see here, all of the security alerts by product are now only the highs. The graph is only the highs. Here is only the highs. Again, it passes all the way down to all the different web parts that we have. So you can make these visuals so that you can drill down on them and use the data and filter it down pretty quickly. So here, if I just want to see anything from Azure Sentinel, again, you can see it filtered down to show my severity alerts over time. Since it's all Sentinel, it's obviously all blue charts, all one color versus multiple colors. And then here we can see the different entities that came from Azure Sentinel alerts, and then kind of a summary by type. So you can see we have a lot more IP addresses than accounts or URLs in our environment. So one other thing, there is a link here to our community if you do forget it. So you can click on go to Azure Sentinel community, and this will take you to our GitHub. We have many sample dashboards, detection queries, hunting queries, playbooks, workbooks, all of those types of things are here. And then we'll dive into playbooks here for a moment. So again, playbooks is your automation for responding to security alerts. This could be enriching an incident. It could be prompting the user. It could be opening a ticket. So there's all kinds of things you can do here. You can see we have many different playbooks, but I'll show you one that's a little more advanced that we did just to show you the power of these playbooks. So here we have a playbook we created. So a couple things about Logic App. You can view it in this design view where it's very easy to add steps. You can search all of our native connectors. We have about 100 plus connectors. You can also build your own connectors, and that's very easy. You just need a Swagger or Open API spec, and you can upload those to make a connector. You can also build one in Postman very easily and upload it. You can also see them in a code view. So if you have developers that want to write them this way, this is called workflow definition language, but they can write them there. I much prefer this graphical way. But you can see here when a Sentinel alert is triggered, we are opening a ticket in ServiceNow. We're also posting a message in Teams for the SOC. We'll send an approval email to the manager like we talked about a few minutes ago. And here I'm asking them, do you want to block this user and IP address or ignore it? And so they will actually get an alert with these details and 2 HTML buttons. And this Logic App will run and wait for them to click that button, one of the 2 options. And then based on the button that they click here, you can see we're looking at the selected option is equal to block user and IP address. And if they say that, we will actually go into Azure Active Directory, and my connection's broken. So there we go. And we will actually set the account to disabled, or account enabled equals no. And then we built an Azure function which allows you to run code that will call our Palo Alto REST API. And so we just pass in the IP address that we want to pass to that function. And once it receives that, it will make a call to the Palo Alto REST API and add that to a block rule on our Palo Alto. And here we're saying if they selected no or ignore in this case, just go ahead and close the incident that we opened in ServiceNow. So you can see how all of this would normally take someone to send a message on Teams. They got to go into ServiceNow and open a ticket. They got to go send that email, or IM that person and bother them and ask them to respond. Then go actually take action in the source products that you may want to make changes to. So now we've automated all that, where a SOC analyst would not even have to be involved in this. You could have this automatically run, or they could just manually run the playbook and it would triage once the manager clicks block user IP. So I'll show you one more before we run out of time. The enrich one for IP reputation. So here's another sample you may want to run manually versus automatically. Here, I'm basically saying when the alert is triggered, this is storing my API key. I get the incident, I get the IP address that is part of the incident, and you can see here we're using that entities property. In Logic Apps, every action has inputs and outputs, and those outputs become dynamic properties. And so you can see here we have all these different various dynamic properties we can use through the various steps. And then I'm saying for each IP address, go ahead and go to VirusTotal using their URL, my API key, which I stored in a variable up here, and then the IP address dynamic content. Parse that data out. And we make this very easy too, because you can go here and say, here's the sample JSON. So I just went to VirusTotal's API, saw what their output was, pasted it in here, and we build a schema for you. So you don't have to build a schema from scratch. It's very easy. And then I look at the actual, because I'm parsing this JSON, all of these properties become dynamic properties. And you can see here, let me just click, I'll add one real quick. So you can see all of my dynamic properties that are returned from that parse JSON. So the response code, the schema, the type, etc. So I'm using response code to see if it's a 1 or a 0, because that's what VirusTotal returns. 1 means it was found, 0 means it was not found in their database. And so if it's a 0, I basically just write a comment to the incident saying that VirusTotal did not find any information for that IP address. So for each IP address, it would add a comment. Here, I say if it is found, I want to take that data that's returned and write it into log analytics in a custom log name. So I'm writing that data in very easily. And then here I'm also adding a comment saying it was found, and here's the query you can go run to see that data in log analytics. So then the analyst would see that as a comment. They could take the query very, very easily and go query and get the results of that VirusTotal response. So I will try to answer some questions, and we'll jump back since we have a couple minutes left. We're also sharing a link to some training we put out so that you can learn Azure Sentinel on your own. So feel free to go to this blog and start going through the training yourself. But I will try to answer some questions in the chat window now.